Hello everyone and welcome back to Newton's Academy past paper review for grade 12. Today we will be breaking down a math past paper question and that will be on the topic of trigonometry. So let's get right into it. Question 9. Question 9 gives us two trig graphs. It tells us the graphs of f of x equals cos x minus 45 and g of x equals negative 2 sine x are drawn below for the range or interval, the interval or the domain of x is between negative 180 and positive 180. The point T is an x-intercept of f as indicated on the diagram, and they've drawn for us our two graphs. Now before we go and answer the questions, let's just see what the two graphs are that they have given us. So firstly we have a cosine function and we have a sine function, and what you should always do is you should identify how these have changed from the original graphs of that trig ratio, meaning how does this differ from a normal cos x graph and how does this differ from a normal sine x graph. So for the first one, we see that everything is the same except for the fact that there is a shift that has taken place. Namely, a right shift has taken place 45 degrees to the right. So it will be a normal cosine graph which has been shifted 45 degrees to the right. So we can see for a normal cosine graph, the turning point would be there, but this one is obviously shifted 45 degrees to the right. For g of x, we can see that there's no shift taken place. However, there has been firstly an increase in amplitude. So instead of 1 it's 2, so it has been doubled, and then also there is a negative in front, which means it has been inverted, meaning it will not reach a peak first but rather it will reach a trough first. Okay, looking at the first question asks us to show that cos x minus 45 equals negative 2 sine x, to show that this expression can be written as tan x equals negative 0.2612. So basically we are equating our two trig functions. So we will have to apply our identities and our trig rules to try and show that this expression is true. So let's see where that takes us. So question 9.1. We need to now solve for this expression and make it in terms of this expression. So let's see, the first thing we can do is we can expand our cos ratio in terms of a compound angle. So that can become cos, it's a cos compound angle. So we'll have cos of the first angle, cos of the second angle, and then we will sign change. So instead of a negative, as we see in the middle there, we'll have a positive, and then we will have sine of the angle and sine of the second angle. Okay, equals negative 2 sine x. Okay, right, now we know that cos 45 and sine 45 are special angles, so we can go and substitute their values in. So we have cos x and we have root 2 over 2, and we have sine x root 2 over 2 equals negative 2 sine x. We can now take over the sine x because we have sine x, so we can add this as we would in algebra. So we have cos x root 2 over 2 equals negative 2 sine x minus root 2 all over 2 sine x. And we will see that when we simplify that, we will get cos x root 2. Why? Because we're going to cancel the denominators on both sides, and obviously we're going to multiply or make a denominator the side. So we have to, if we have to make a denominator of 2 here, we will also have to multiply 2 there, and we can cancel all the denominators. So we get on this side here, we will get negative 4, negative root 2, which comes from here, negative 4 and negative root 2 there, and we take sine x out as our highest common factor. Okay, and then dividing both sides by cos x, we can get our tan ratio. So this gives us tan over here. So we can have tan x and then negative 4 minus negative root 2 equals root 2. And then obviously we just take over that part of the term as a division, and we will end up with the expression that we had, or that the question asked us to find, which is negative 0.2612. Okay, so we have proved that expression to be true. Question 9.2 asks us, solve the equation cos x minus 45 equals negative 2 sine x for that interval, or for that domain. So basically this is already giving us a hint saying we need to use this first question, because as you can see, these two expressions are the same. So they're basically asking us to solve for this expression for this interval, meaning we have to determine the values of x for which this expression is true in this interval. So basically what we are doing is we are finding the general solution and substituting in values of k to give us the answer to that general solution. So question 9.2, we already have tan x equals negative 0.2612. We determine our reference angle, shift tan of 0.2612, and we shall get that to be 14.64 degrees. So we can go and we can substitute that in one of our general solutions. So we know that x will equal to, and then in tan is negative in quadrant 2 and in quadrant 4. So in quadrant 2 we have 180 minus our reference angle, so minus 14.64 plus 180k, because that is the period of a tan graph where k is an element of z, or an element of an integer. And when substituting values of k into this formula, we can then get values for x obviously within that range, negative 180 to positive 180, or within that interval. So substituting when k is 0, then we get x to be x equals 165.36. That's when k equals 0. And we get x to be negative 14.64 degrees, and that's when k equals negative 1, because those are the only two values of k which give us x values within this interval. Okay, so we have now solved for the expression. Okay, let us move on to 9.3. 9.3 simply asks for the coordinates of point T. It tells us to write it down, so we don't even have to show a calculation. So the coordinates of point T, let us write it down here, 9.3. The coordinates of point T is an x value of 135 degrees and obviously a y value of 0, because we see that it's an x-intercept. But now you might be wondering, okay, well, how did we get that value of 135, right? It's quite plain to see that the y is 0, but how do we get 135? So it narrows down to what I was talking about earlier of, we need to see how this graph deviates from our original cos x graph. We said it is a right shift of 45 degrees, and we know that the x-intercept of our original original cos graph is at 90 degrees, and we said this graph was a right shift of 45 degrees. So that gives us the new x-intercept to be at 135 degrees. So just again to repeat, the normal x-intercept of a cos x graph is at 90 degrees. So we simply shift that 45 degrees to the right to get the x-intercept for this graph here. Question 9.4 asks us to write down the interval for which f of x, the graph of f, is greater than and equal to g of x. So f must be above g of x. When f of x is greater than g of x, it has to be higher than g of x. So we see here it is below g of x. We see in this small portion it is below. So it's obviously between the two points of intersection, which is basically what we solved for in 9.2. Why? Because we equated the two graphs, so we had our points of intersection, and they said when f of x is greater than, so it's in that portion, and equal to, meaning we will include our points of intersection in that as well. So writing our interval for 9.4, we already have the x coordinates of our point of intersection right there. So what we have to do is we have to form an interval with that. So they wanted the interval for which f of x is greater than and equal to g of x. And that will be between our two points of intersection. So one way we can write it is starting from obviously our lower x value, and we say less than and equal to x, less than and equal to. Why? Because they told us it must be including the point of intersection, and then our second x coordinate of the point of intersection is 165.36. Alternatively, we could have wrote it as x is an element of including negative 14.64 going all the way to 165.36 and including that as well. So these were the two ways of forming that answer. Alright, question 9.5 asks us to write down the interval for which both f and g are strictly increasing. That means for which f and g have a positive gradient, and they must both have a positive gradient simultaneously. So at the same time, they must be increasing. So looking at our graphs, we see that f is decreasing here while g is increasing. We see g is decreasing here while f is increasing. The only portion, if we put our ruler, so to speak, and look where both graphs are increasing, is between the turning point of g here and the turning point of f here, because f is increasing there and g increases there until the turning points. So we simply need to determine the x coordinates of the turning point. Well, given that this is our sine graph and it hasn't been shifted, we know that the one coordinate of this turning point, or the x coordinate, is negative 90 degrees. And we know for our cos graph, we know normally the turning point is at negative 180. But this graph has been shifted 45 degrees to the right. So we have to add 45 degrees to negative 180. So 9.5, if we take negative 180 and add 45 degrees, then we get negative 135. So therefore, the interval for which both graphs are strictly increasing will be between negative 135 and negative 90 degrees, which are the two coordinates of our turning points. Notice we do not have an including sign here. Why? Because if we include it, that means we're including the turning point, and the graphs do not increase at a turning point. A turning point is known as a stationary point. The gradient is 0, so therefore the graphs are not increasing. And alternatively, you could have written it as x is an element of not including 135 degrees all the way up to negative 90 degrees and not including that. Okay. Lastly, question 9.6 asks us the graph h is obtained when the graph of f is shifted a further 45 degrees to the right. So it was already shifted 45 degrees from our original cos graph, and they're shifting it 45 degrees once again. Write down the equation of h in its simplest form. So 9.6 tells us that h of x is equal to cos of x minus 45, and then we're shifting it another 45 degrees, so we subtract a further 45, so that is cos of x minus 90. And what we can do, we can rearrange this to put it in cofunction form. So that will be cos 90 minus x. Notice that our signs have changed. Initially we had negative 90, now we have positive 90, and we had positive x, and now we had negative x. But that does not mean we will take out a negative here in front of cos, because for our cosine ratio, it is the only trig ratio where we can manipulate the sign of the brackets and we will not have to sign change in front of the term. And then we can lastly simplify this to give us sine x, because that is a cofunction, and 90 minus x is positive. It is in quadrant 1, so we get sine x. So that also allows us to see that a cosine graph shifted 90 degrees gives us a sine graph. So the simplest form of that expression will be hx equals sine x, and that gives us the equation of h in its simplest form. That brings us to the end of question 9 on trigonometry, specifically trig graphs, and thank you everyone for watching.